Hello everyone, welcome you all to a 2 week course program on linked list. So today I will give you a brief introduction on linked list. Myself, Dr. Anwesha Mukherjee, currently working as an assistant professor in the Department of Computer Science, Moishada Raj College. So these are my contents. Now what is a linked list? A linked list is a linear data structure that contains a group of nodes, where each node points to the next node through a pointer, and each node contains data and reference to the next node. So, what is a linked list? Linked list contains a number of nodes where each node stores data and address of the next node that can act as a reference to the next node, that acts as a reference to the next node. Okay. So in this figure, you can see we have three nodes 7, 4, 16. These are the values these nodes contain. And at last we have end. We have at the end we have null. Actually, the 16, the node that is containing the value 16 is pointing to null because here we have only three nodes. So here you can see from this figure that each node points to the next node. For example, the node which is holding the value 7, that is the starting node, which we will refer as head. So that points to the next node that is holding the value 4. And that node points to the next node that is holding the value 16. And then the node which is containing the value 16 points to what? Points to null because this is the last node of this list. So what can we say? That a linked list contains a number of nodes where each node contains data and reference to the next node. Okay. So now these are the advantages of linked list. Linked list is a dynamic data structure. So based on the user requirement, memory can be allocated based on the user requirements to store data and all these things. So during based on that, the list can be generated, and it is obviously a dynamic data structure because in case of array, usually what happens, we have seen that we have to previously declare the size of the array. But here what happens usually that during the runtime, actually you are allocating memories based on the required data amount. Suppose at first the user has entered 5 nodes to create a linked list. So after the linked list is created, then the user can insert more nodes according to the requirement. So that's why it's a dynamic data structure. No need for an initial size that I have already mentioned. Required memory allocation whenever if a node is not required, if the data have to delete a node, we will make the memory free also using a free function. Okay, so only the required amount of memory is allocated, which is very beneficial. No need for shifting element after insertion or deletion, only the address present in the pointers are updated. In case of array, what happens if we have to insert an element, we have to shift other elements because in case of array, the data are stored sequentially. But here what happens that if you want to insert a node, you have to just only update the pointer. Suppose within 2 nodes I have to insert a node, only the pointers need to be updated. Okay. So these are the types of linked list. We have single linked list, circular linked list, and double linked list. Linked list have several applications. Linked list can be implemented in other two types of data structures we know, which are familiar, the stack and queue. One is the last in first out, and is first in first out data structure. Um, Many operating systems use double linked list to maintain references to active processes, threads, and other dynamic objects. Hash table may also use linked list to store the chains of items and hash to the same position, the hash table. So, outline of the next lecture will be on single linked list, create, update, and display of single linked list. Thank you.